Hello and welcome back to compiler programming. In last video we made this very nice function work, so now we can have multiple arguments and we can have addition working, including like multiple additions in a row. But before we continue with the topic for today, I wanted to do a slight refactoring and change some of the approach that we took in the last video. In particular, I had a little thought in the back of my mind and I realized that it would be nice if this part that turns integers and IDs into actual values would not happen before we try to match the sum, but afterwards. And in fact, any kind of stuff that changes a single token into value should actually be deferred as much as possible. So this is what I want to do. I want to say value star token force value. And what it will do, it will get a token. So it will say token star token. And then it will do what we were doing over here. Right, so we'll take this stuff, we'll put it over here, and this will also allow us to simplify this code quite a bit. So we can remove this stuff, and say return result token. Maybe we can even do better and move this stuff over here and say value star result value is 0. Here we will say assert value, and in here we'll just say result like this. Result value is this stuff. And here it will be something else. Here it's even easier. We just say result value is scope lookup. And if we get 0, we will have an assertion over here. So that seems good. We should remove this assertion because right now apparently we can only pass parse integers that is 42, which is not really very nice. But this looks much better to me. In fact, since we're doing an assertion here anyway, we might even do it like this. And no, actually, I like this version. Return result. Should I do value star? Let me think about this for a moment. Actually, yes, we don't even need this stuff at the moment. We can just do it like this. Yeah, and return result value. We need to add a few more things here though. So if expression type is token type value, then we return this actually no longer expression. This is now token, and if it is a value, then we need to return 1. So we say token value. And otherwise, for now, assert. For now, I'd say not implemented because I'm not even sure which tokens can be converted to values, which cannot. So if we get over here, this is what we'll get. Scope is undeclared value. That is fine. We can pass on the scope. And here we say result value. So this thing is like this. Okay, that looks good to me. That means that we can remove this stuff, but over here, when we get left hand side and right hand side, we can right away wrap it in token force value. So that means will be value LHS, and this is like this. And we need to pass on the scope. And then the same thing for right hand side. Notice that we also means that we don't need these assertions because they will be folded into the outer thing there. So that's very nice. Okay, and that looks pretty good to me. Let's see if that actually works. And you replace undeclared identifier. Yeah, that's fine. I probably can turn this into a for loop as well. Yeah, let's do it like this. For bool, did replace is true, did replace, and at the end we don't do anything, but at the start of the loop we do did replace false. So something like this would be okay. Means we can remove this one. And here we can do right away like this. And this looks good. Let's try to run the tests and see if the refactoring was actually successful. Apparently it wasn't. So let's see what is going on. We need to go to line 445, and here is the result. So we failed to merge this into a single thing. Well, that's fine. Let's try to see what is going on. Let's go to this test. And since the first one is already one failing, we can just go directly to this thing and see what's going on. Since we were actually editing the expression parsing, I can probably directly go to expression parsing as well. Yep. So there is one thing in the array, I would imagine. So state, root, children, data, length. Yeah, we have one child. Okay, so let's start here. We didn't replace. We get the first one. I get expression. Oh, yeah, I know what I forgot to do. So I didn't even to really debug it, because here I also now need to wrap this stuff, force value of like this. Don't need this stuff. Forgot and start here. Okay, I need to pass in the scope. Okay, let's try that again. And we have a winner. So we can add this to index, and I like this version much more. So now we have a pretty nice setup. Okay, So that cleans up this part. I'm also considering to slightly clean up this comma situation. And my idea would be to extract this comma outside of here and into the place where we actually call match argument. I think that is in general a bit easier to implement. We also will not need maybe, so let's just say token match operator. Where are you? So you're here. And what do we do? Okay. We go through this thing once, and then we say maybe token match. And it's actually not really much better than it was before. Okay, let's leave it like this for now. It's fine. Cool. Let's think about what is the next thing that can be done. Well, if we consider what else can we do in general, we need to have a concept of, we definitely need more operators, and we need the concept of a variable, I guess. We also need to be able to call other functions, and I think that is the next thing I will try to do. So first things first, if we need other functions, we actually shouldn't start with this match function call. We should have something like match module or whatever, because we need multiple functions to be grouped together. So that's, I guess, the first thing. And another one is around the fact that I'm a bit cheating right now, and I'm saying that this whole thing is a function definition, but in reality what I want to do is I want to only for this part to be kind of function part, and this is just a standard way to define a constant value. And that would mean that we already need to split up the current code into two parts. One that will deal with this stuff, and another one that will deal with this. Which means we will need to do some stuff like this, right? So we'll need to go through this code and then find a particular pattern in it. In reality, we are probably searching for this arrow and then checking that on the left side and on the right side we have what we expect to have, and we will fold this into a function. So this will be again a value, right? Because in general setup that we have, functions are just values like anything else. They just have a specific type and have specific things associated with them. So let's think of how this might work. I would like to avoid replicating this stuff multiple times. So it doesn't look like we actually want a state here. Instead, we just want an array of things. We don't particularly care whether this array is part of some token or not. So I can say array value or token pointer, or actually let's get the token for now. token star token. Okay, we can do assert that token type is token type expression, or actually token type paren, sorry. Token type paren or token type block, right? These are the things that can accept this stuff. The rest should be pretty fine, where I can just say, or let's name it root. I like root. Okay, obviously we have problem where we are calling this stuff. Sorry, this is not a block, this is curly. I was saying curly, I was thinking block. And here we no longer need this stuff, we can just say body. Okay, that looks good. That's fine. What else can we clean up over here? Well, we definitely need a builder because we need to know, like, we need something to push our instruction to. Maybe later on it won't be a function builder, but something like a code block builder, but for now that's fine. We have a scope, which we need. We have a program, which we need, I think, for other stuff here. Like, do we need a program? Doesn't look like we do. Okay, well, if we don't need the program, that's better. Okay, I like that. Okay, now we need to create a new thing, which will be something like token match module. It will get a token. First thing is we assert that token type is token type, module. And what does it return? That's an interesting question. I think long term it will return errors to us if there were any, and right now is actually a void thing, because we expect to match the whole input, but there is no direct output. I mean, again, long term maybe it will also return like all the exported things in the module, but since we don't really have that concept at the moment, it doesn't really matter. So let's just stick with void for now. Okay, what do we do though with the module? Well, the idea is that we do exactly the same thing as we do over here. We are just using different operators, let's call them that, which is, I guess, fine. Okay, so let's copy that. First we check this, right? If there is nothing, we return. I think empty module should be okay. Why not? it will fail later on because we will not know which function to call, but as far as emptiness goes, that's perfectly fine. Okay. Now let's figure out what we want to do here. And this is where we have these diversion methods for matching stuff. In case of plus, we were just looking for plus and then just checking on the left and the right if that's okay. And that, I think, is generally preferable method because it will have way less false positives than the other one where we just get it in sequence one by one. So I guess we'll go for this version for now and then figure out what to do later with the other thing. Yeah. I mean, I could merge them together, sort of. Where I will first look for this thing and then only later deal with it. Okay, let's just start pretty easily. So we have this arrow and we want it to not be at the start, and we also want it to be to have at least two things on the right side, right? Let me go here. So if we're looking for this thing, then on the right side we should have this stuff. Eventually I want to get rid of mandatory return type. So maybe we don't want to have mandatory two things on the right side. Maybe we can get with only one. How would that look like? Let me think. Have this token match. Where do we use this stuff? So we use it for arguments and we use it for the function. Well, let's just keep it, honestly, and then we figure out the efficiency later on. So here's how it's gonna look then. We need to have this token match state, right? So we'll put it over here and we say token match state state match state, actually like this. Token state is okay. Root is token. That's good. And then I can say that state child index is, I can actually replace this I with the child index and say this is like this. Actually, I'll just say I. Okay. And now that means that we can actually use our stuff here to do the matching. So we say use 64, what is it called? I forgot. It's called pick index. Okay. Pick index is 0. And now we can match. The only thing is it will it will try to return 0, which is not necessarily what we want. So I think I do like this function, and I will continue using it, but the rest will sadly not be very useful long term, but that's fine. The whole thing is pretty iterative process, and I'm okay getting rid of the parts that are not necessary as long as we are making progress in some direction. Okay. Token pig match, token type is token type paren. Yep. And that would be args. So token star args. Here I can say like 0. In reality, I don't even need to do them in order, but I guess I'll do it like this. First, I will try to match the arrow, and then if arrow doesn't match, then we continue. Right, because arrow is what is making arrow is the function definition. The rest is just other things, and they can appear in other places in the source code. So we can have parentheses in other places, we can have curly braces in other places, but if we see arrow, we basically know that it's a function, so that means that we can do this check first, like we do look ahead over one thing. So imagine that we are over here, right? We are at this position. We skip this stuff and we look ahead here and we realize, okay, this is an arrow, and only after that we check, okay, on the left side is this stuff, and the right side is this stuff, and like we can go from there. Okay, and if you found an arrow, we basically now can assert that all other things need to be there. So we have args 2, 3, 4. Okay, this is paren. The arrow is something that we can put over here. And we can say like slice literal arrow. Okay. And the rest is pretty easy. This is curly and this is paren. And this is return types. And this is the body. Okay. Now we can assert that we have args and assert return types and assert body. And this is where we would eventually to do show proper errors to the user, right? But we already went through this similar process with tokenizer itself, so we know we can do, once we have assertions, we can easily turn them into errors later on. Okay, so we get the arrow, blah, 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 we do this stuff, we get there, and over here, now we need to do things. So I will keep this stuff here because we do need to do this. but this, all of it, I guess, can go. Instead, we will do what we were doing over here. So I'll take this stuff. And I will put it over to here. Okay. That looks good. Let's try to just build it and see where are the errors. Now the first thing is now we can get rid of this stuff. There is not going to be token match function anymore. If we extract it later, that's good. But for now it doesn't exist. This should be source equals. And here we say token. Okay, that's good. Token. In fact, here we can say that I expect us to arrive at exactly 0 children. So we should get into that. And this is where the funky part begins, where we need to merge our previous approach and the new approach together. Okay. What do we need to do? Well, we need to create one of these, right? So token star result token is stamp allocate of token. Okay. Parent is token parent and source is token source. Okay. We don't need pick index. We actually don't need this stuff. We do need this stuff. That's fine. Maybe we'll change how this is done later, but for now that's okay. And now we only have problems in our tests. But before we continue this, they will fail anyway, because we are not doing what we need to be doing. First of all, this needs to be plus 3, I believe. We have this stuff which will remain, and then we getting rid of this tail. So yes, it is plus 3. Just to remind you, what this thing does is we match this part and then we replace it with a single token, which means that we keeping this stuff and replacing it, and then this part of the array goes away. So this seems fine to me. Plus 3, yeah, this seems good. Okay, but this is only the first part, and the second part is where we do some definitions, because where do you start from? Okay, so like this, because previously, as I mentioned, we were treating this as a part of function definition, but that's no longer the case. Only this is a function definition, and that means that we need to now do this part. And this part is pretty straightforward, where we can do similar thing to this, right? We have token star define So basically this colon colon, right? Again, needs to be one offset. If we didn't find it, we continue. And we have a name, and we expect it to be an identifier. And then we have value token or in value, where we say that well, I don't think we should actually match it on anything. We should just get some token. Yep. But we want to force the value like we did with the other thing. So we say token force value. And we pass in program global scope to it. Again, later on it will be probably module scope, but for now it is a global scope. So this now turns into a value. This is a value. And it's like this. That seems good. And what else do we need to do? Well, we are starting with I. Yeah, that's fine. That's actually I here. And this is now I plus 4 because I changed how it works. Yeah. So it's like this. And here it is I and I plus 3. So we're replacing 0, 1, and 2. Yeah, that's fine. Okay. This is fine. And one final thing is we need to do scope and define of program global scope, and we have name source and value. Okay, that looks fine to me. Just to reiterate what I'm doing, at first we're trying to reduce this part into a single token value. If we're successful, we will do a pass where we'll try to reduce this stuff plus the newly reduced value, so into just a named thing in the scope, right? So we'll have a named entry called plus, which will be our function if everything goes according to plan. So I will comment out these two tests for now and just work with the single one over here because we are the less variables we have, the better. And here we need to change some things around. So we can say token match module, and we can pass a root. We don't need this part anymore, so we can just pass in like this. And we need to pass in the program. Okay. That's fine. And now we need to look up the function. So for that purpose, we need to do the following, where we are saying that value star foo is scope lookup of program global scope, and we are looking up foo. Slice literal foo. Okay. I don't think it matters at which point we do program end. Here we can do fun and like this. Well, that's quite a lot of changes. So I will try to step through this thing with a debugger right away because I don't trust that we made it right. Let's just try it in there. Okay, ding ding ding. And let's go into match module. Okay, we go through here, we go through here. We now trying to match the function. Okay, we didn't match the arrow, so we continue. Okay, next we also didn't match the arrow, we continue. Now we should be matching the arrow. So arrow now should be, apparently it isn't. Am I missing something? So what is I? I is 2, so 0, 1, 2. I would expect to match the arrow right about now. Oh, yeah. It would, if only I didn't make a mistake by saying that this is a parent, this needs to be an operator. So that means that here it's also broken. Okay, rebuild and try again. I will put it over here right away. And let's run, not arrow, not arrow. And this time I expect it to be an arrow. And indeed, now we have it. We get the args, return type. Everything is great. This will go through the whole thing. We get the function scope. Okay. We get over here. Yeah, we don't have any arguments there. That's fine. We have one return type, so we parse it. We freeze the function. We try to match the body. This should be perfectly fine. We have an alt breakpoint, so that's okay. So we will go through the whole matching. It's good. So we should have a body result, which is an immediate 64. That sounds great. We return that body result. We finish with the function. We allocate the result token. And now the tricky part, if I didn't mess up what we wanted to do. So token, children, data. It had 6. We should end with 3. Apparently I did mess it up. So it should be +3. Wait. This is zeros. 1, 2. No, this should be 4. Check. Yeah, I'm definitely getting to this. So this is a bit fishy. Maybe the whole delete function is not actually working like it's supposed to. Oh yeah. I think I know what the problem is. This should be I plus 1 to I plus 4, and this is I plus 1 to I plus 3. Yeah, that's actually fine. No, here I want to remove everything. Here it's actually correct, but here I want to only remove the other part. Okay. So let me take a breakpoint here. Right. Start again. Good. And what is the token? Children length. Okay, now length is 3. That's much better. I can do token children data items 2 is the interesting one. I think really the whole arrow and dot thing is my biggest problem with C. Okay, and it is type value. Okay, that looks pretty decent. Let's try to continue and see what happened. Now we try to replace it again. We never find the arrow, so no need to do anything. And now we try to match this stuff, and it should match on the very first try. Yep, it did. We get the name, we get the value, which is pretty good. So value is a function like we wanted. Everything is great. We are replacing it. We should be left with the 0 children, which we are not, because there is a bug somewhere, I guess. That's the wrong thing. Yeah, I should be looking here. Yes. Okay, that's fine. We check that we have 0 children. We do, and we are done. We run program end to actually output assembly code, and then we get foo. Foo is our function. So we assert that we get foo, we get the checker, and we check that it's 42. Great, great, great. Okay, all the tests are running, so that's good. And now we can try to uncomment other 2 tests and see how they are. Well, first of all, we need to change how we are doing things. So this would be like this, I guess. Okay, even this is not necessary. Okay, that's fine. And let's uncomment. Let's run tests. Just go one by one. This is still good as well. And one final one, which is a bit more complicated. We do it like this, and we get, now it's not the foo, now it's the plus, which is a good test to have as well. So we are trying to get a different name, and test. Great. I think that will be it of the day. That is pretty nice progress. Now I know much better what is the general setup I want to have. Obviously, it wouldn't be great if we end up with this gigantic function over here. So I will also need to figure out how to make it more modular, but that is fine for now. And the biggest thing now is obviously we have this stuff over here, which means we can, do some kind of scope definition on the module scope. Actually, now that I'm thinking about it, if we done everything right, and I think everything is fine, it should be possible to do multiple functions. So let's do that. Let's do it like this and say one return one, and then two returns two. Okay, and we have one is one, and this is gonna be checker one. Actually, we'll do it like this right away. Check that this is one. Okay. And we have also two. Okay, something like this. It builds, but does it work? Yeah. Parse and run multiple function definitions. Great. So that's actually really good. That means that I guess in the next video or so, the next thing will be to actually try to parse our own calls to the function, so we can make like 2 call 1 or something like this. But this is pretty good progress, which means we now have multiple definitions, and it also opens up very nice things like imports and so on and so forth. But that will be it for today. Thank you very much for watching, and hopefully see you next time.